Hello, it's me again. Here we go again. I'm kind of looks like I'm becoming addicted with this, and I like it, but I'm not sure the additional benefits of doing this relative to the additional cost associated with doing this. Let's take another hit at it. So anyway, this time around, I want to continue on with the emission issues, and what I want to talk about in this video is to look at the optimal emission level. What you see in front of me is basically what I did in the previous video, and it shows you basically the marginal abatement cost curve for firm A, marginal abatement cost curve for firm B, and the total marginal abatement cost curve of both of the market, of the industry. Okay, and you can see that if you leave the industry unregulated, firm B will be emitting here 40 units, and firm A will be emitting 40 units also. So the total emissions would be 80 units, and they basically are not paying anything for those emissions, so the cost is basically zero. Um, and if you want to reduce emissions by 1 unit, it's the more efficient firms will reduce it at $100, so they come in first. This firm will not come in until the price hits $200, as I said last time, and then they'll come in. Okay, so you can think of this marginal abatement cost curve here. Up to 40 units reductions is really effectively firm's A marginal abatement cost curve, and then from 40 units and further reductions, the firm B comes in with the higher cost. So you can see the firms that are more efficient at reducing pollution come in first, and then the less efficient firms come in to take on the responsibility of reducing emissions further. Okay, so the firms unregulated are emitting 80 tons of emissions of sulfur dioxide emissions in this case that we did in the classroom example, and it could be possible that this is the optimal level of pollution, but it could be that it's 60, it could be that it's 40, it could be that it's 20, or it could be that it's zero, or it could be any number in between, right? We don't know the answer to that. What we need to know in order to answer that question is basically the idea of, okay, this is the this shows us the cost to society of reducing. What are the benefits to society from reducing? Well, the benefits to society from reducing arise basically from reduction in damages that the current emission levels are causing. Um, and so what we need is basically a damage curve and how the damages change as emissions change. One assumption that we can make, not the only assumption, but one assumption we can make is basically that as emissions increase, the additional damages that they cause increase. So the marginal damage curve is as follows. It rises, sorry, I want do what I did in the other class, in the afternoon class, but it rises the additional damages caused from additional emissions increase as emissions increase. Okay, again, it's the additional damages. So if we are emitting, let's say, 20 tons, the additional damages caused from an additional unit would be at the margin about $50 or so, or $60 here. I don't know what the exact number is, but anyway, around there, $50 to $60. Okay, the total damages caused by 20 tons of emissions is the area under the marginal damage curve, just like the total cost of reducing emission is the area under the marginal abatement cost curve. Okay. So, if we are operating at 80 tons of emissions, completely unregulated, if we reduce emissions by 1 unit, the damages that we reduce the damages by about $200 per unit at this level, right? So, and it's costing society $100 to reduce it by 1 unit. So the benefits that we get from reduced damages far exceed the additional cost to society of reducing emissions. So it's optimal for us to go this direction. Okay, so and we can continue on doing that as long as the marginal damage is above the marginal abatement cost curve. So if the marginal damage is greater than the marginal abatement cost curve, reduce emissions. Yeah, and you keep on reducing. And once you hit the 60 units here, you don't want to go any further. And the reason you don't want to go any further is because the additional cost to society is a lot higher than the additional benefits that we get from the reduction in from further reductions in damages. Okay, so the optimal level is 60 units of emissions. Okay, notice that if the marginal damage curve was something like as follows, rises very, 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 very steeply, like that, then it would be optimal actually to bring it even down to 20 units, right? Um, And there are indications for climate change that we should start with a small carbon tax, and then as things get worse and worse and worse, start rising the tax rate. Then so start with a low carbon tax, and then start increasing it further into the future. Although some are suggesting that, some are objecting to that because of the irreversibility of disaster happening. The damages could be irreversible. In other words, once they occurred, you cannot reduce them any further. You cannot. It's very hard to reduce them. So that's a big issue in climate change. But anyway, so you got the picture. I hope you got the picture. Anyway, I'll stop here. I think that you got the picture. Anyway, so let me just finish. Oops, let me just finish up by saying that the government can set the tax rate at $150, and if he sets the tax rate at $150, then this firm will pay to the government $6,000, which and this firm will pay, if they stay at 40 tons, $6,000. But so this firm will say, well, let me what if I reduce it by 1 unit? If I reduce it 1 unit, it's going to cost me $200, and my tax savings is only 150, so I will not reduce. I'll stay at 40. This firm, however, will say, well, if I reduce a little bit, I'm going to save $150 of from paying the government, right, per unit. And it's costing me only $100. So I'll go ahead and reduce, and I'll keep on reducing and keep on reducing and keep on reducing until I hit 20 units. I won't reduce any further because the reason if I reduce any further, it's going to cost me $200, and my tax savings is only $150 per unit. Therefore, I will not reduce any further. So this firm will stop at 20, and in fact, that's exactly how much we need to reduce to get to the optimal level of emissions. So there you go. 80, the unregulated level is not the optimal solution. 0 is also pollution is not the optimal solution given this technology, and it looks like 60 is the optimal solution. Now again, think of there's a strong incentive structure here for firms to adopt better technologies at reducing pollution, because then they will benefit a lot more. Even this firm might want to change to this firm and make money, or not pay so much taxes, put it that way. Not make money, but not pay as much taxes to the government relative to what it would be paying if they had the old abatement technology. Cheers, thanks, bye.